Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 6, Section 1, Chapter 3, Topic 6. Reliability testing is a crucial aspect of semiconductor manufacturing, aimed at ensuring the quality, durability, and reliability of packaged devices under various operating conditions. This process involves subjecting semiconductor packages to rigorous testing methodologies and techniques to evaluate their performance and durability. Among the common reliability testing methodologies are temperature cycling, high-temperature storage, mechanical shock and vibration testing, humidity and moisture testing, and electrical stress testing. Let's delve deeper into each of these methodologies. 1. Temperature cycling. Temperature cycling involves subjecting semiconductor packages to repeated cycles of temperature extremes, typically ranging from low to high temperatures and vice versa. This testing methodology is designed to evaluate the thermal cycling reliability of semiconductor packages and their resistance to thermal stress-induced failures. By subjecting packages to extreme temperature variations, manufacturers can assess the integrity of solder joints, interconnects, and materials used in the packaging process. Temperature cycling helps identify potential reliability issues related to thermal expansion and contraction, ensuring that semiconductor packages can withstand temperature fluctuations encountered during normal operation. 2. High-temperature storage. High-temperature storage testing involves exposing semiconductor packages to elevated temperatures for an extended period, typically ranging from hours to days or even weeks. This methodology aims to assess the stability, aging characteristics, and reliability of semiconductor packages under high-temperature conditions. By subjecting packages to prolonged exposure to elevated temperatures, manufacturers can evaluate their long-term reliability and performance. High-temperature storage testing helps identify potential degradation mechanisms, such as material aging, solder joint creep, and diffusion processes, which may affect the reliability of semiconductor packages over time. 3. Mechanical shock and vibration. Mechanical shock and vibration testing simulate the mechanical stresses and strains experienced by semiconductor packages during transportation, handling, and operational use. This testing methodology involves subjecting packages to controlled mechanical shocks and vibrations using specialized equipment. By simulating real-world stress conditions, manufacturers can evaluate the structural integrity and reliability of semiconductor packages. Mechanical shock and vibration testing help identify potential weaknesses, defects, and structural failures that may occur due to mechanical stress, ensuring that semiconductor packages can withstand the rigors of handling and operation without compromising their reliability. 4. Humidity and moisture testing. Humidity and moisture testing assesses the resistance of semiconductor packages to moisture ingress, corrosion, and delamination. This testing methodology involves exposing packages to humidity chambers or moisture-rich environments, where they are subjected to controlled levels of humidity and moisture. By monitoring changes in package properties and performance, manufacturers can evaluate the reliability of semiconductor packages in humid environments. Humidity and moisture testing help identify potential reliability issues related to moisture-induced corrosion, dendritic growth, and material degradation, ensuring that semiconductor packages remain reliable and durable under harsh environmental conditions. 5. Electrical stress testing. Electrical stress testing evaluates the performance and reliability of semiconductor packages under electrical stress conditions. This testing methodology involves applying electrical stress tests, such as voltage spikes, current surges, and electrostatic discharge (ESD) events, to semiconductor packages. By subjecting packages to electrical stress, manufacturers can assess their susceptibility to electrical failures, such as dielectric breakdown, gate oxide damage, and latch-up. Electrical stress testing helps identify potential reliability issues related to electrical overstress, ensuring that semiconductor packages can withstand the demands of high voltage, high current, and ESD-prone environments. In conclusion, reliability testing encompasses a diverse range of methodologies and techniques aimed at evaluating the performance and durability of semiconductor packages under various stress conditions. Temperature cycling, high-temperature storage, mechanical shock and vibration testing, humidity and moisture testing, and electrical stress testing are among the common reliability testing methodologies employed by semiconductor manufacturers. By subjecting packages to rigorous testing protocols, manufacturers can identify potential reliability issues, mitigate risks, and ensure that semiconductor packages meet stringent quality and reliability standards. Reliability testing plays a vital role in enhancing the overall quality, durability, and reliability of semiconductor packages, thereby contributing to the success and longevity of electronic devices and systems in diverse applications and industries. Thanks for watching. Please like, share, and subscribe.